Want to get going?
Yeah. Good. You. Introduce yourself.
This is Will Holick. It's 1 o'clock, so we're going to go ahead and get started here. If we get room to lie down. All right, we are here for the evaluation of the Epoke Bulk Spreader. This is the final results meeting. So we're going to present the research objectives and the outcomes of the research project. First off, the research team would like to thank ODOT. We'd like to thank the technical liaisons, Paul Ensinger, Brian Olson, and Frank Phillips Jr. And also we'd like to thank the research office here at ODOT, Jill, Kelly, Vicky today, and what else? Yeah. So the research objectives, the 4 of these from the project proposal, evaluate the existing data reports with the Epoke unit, assessing the in-field performance of the Epoke, performing a cost-benefit analysis from the research results, and proposing a deployment strategy consistent with ODOT's current practices. So we evaluated other states that were using these or municipalities, and then assessed it from our experiences with ODOT to develop the cost-benefit analysis. So the project setting, this was a 2-year study. You can see the figure on the left is from the first winter, 2011-2012. We deployed the Epoke within ODOT Summit County Garage, which was located in Boston Heights. So the first winter season, we did the study on State Route 8. You can see there on the left that's about a 3-mile span between mile markers, I think 15 and 18. They did bring it down to about mile marker 13 towards the end of the season. And on that figure, the 6 dots that are all numbered there, those are the Bluetooth node locations that we use to capture vehicle speeds. And we'll go more in depth as we go on there. But during that 2011-2012 winter season, there was only 3 snow events. It was a very mild winter. So with ODOT and everyone, we agreed to extend the project another year so we could collect more data and have a better evaluation. So that brings us into the winter 2012-2013 season, where we moved the Epoke onto I-271, which was just a little north of Route 8, kind of northwest. And we just rearranged the study zone a little bit and gave the Epoke a shorter section so the Epoke would treat one direction of the highway while the standard truck would treat the other direction. On 271, the Epoke was treating southbound while the standard truck treated northbound. And that way we could get just a side-by-side comparison and compare the 2 trucks in a very similar setting to see differences in salt usage and level of service that was provided by the 2. This figure kind of shows the data flow of all the data that we collected for the project. You can see kind of 4 areas that we were really evaluating. The equipment, which is the Epoke versus the standard truck, the weather, the salt usage, and the travel speeds. So for the equipment, we compared the labor costs of the 2 different vehicles, the initial purchase prices of the 2 systems, and the maintenance costs that were associated with both the Epoke and the standard truck. And then the weather, we broke that into 4 categories, kind of based observationally on what we saw during the 2 winters. Again, those were 2 kind of milder winters for what we would normally expect in Northeast Ohio. But we looked at pretreatment events, light, moderate, and heavy snowfall events. And then for the salt usage, just comparing the 2 different systems just to quantify the salt differences. Then the travel speeds, which we collected using the Bluetooth nodes. And again, just comparing the resulting speeds in the 2 directions. And then moving down the figure, with the equipment, determine the total costs and quantified downtime. So looking at the differences in labor costs and maintenance, and seeing, is one truck down or more often than the other, or are they similar? And then with the weather, we kind of normalized out weather severity, so we could see the two systems in different snowfall categories. Obviously quantifying the salt usage differences, and then we did look at any resulting level of service differences. So we looked at a few deployment strategies, kind of a short term to see how would you implement the Epoke per event. Then we looked at like a season-wide deployment. Should you move equipment around based on storms, and then kind of change it around based on where your heavier snowfall is going to be. And then more long-term, as far as future purchasing and implementing within ODOT's fleet. And then we do kind of a cost analysis showing payback periods and everything associated with that with the Epoke unit. This is just showing the equipment that was purchased with the project. The first figure is the S4902 Combi spreader, which was purchased for $110,000, and that was a little bit increased over what a standard S4902 would be, because ODOT got the hook lift version to be able to implement within a hook lift truck, rather than a typical Epoke is just built as a slide-in that would go into the bed of a dump truck. And I think that one is $100,000 compared to the $110,000. And then there was the tanker spreader, which is in the top right. That was $56,500. That is the Epoke spreader that was placed on the back of a 5,000-gallon tanker truck, which was used for pretreatment and anti-icing events. Then there's the EpoSat controller, which is the GPS navigation, and which also automates the spreading controls with the Epoke, and that was included with the 4902 purchase. This figure just kind of shows the Epoke Theory. They developed a bit of a different salt spreading application than what most people would consider standard. The main difference that they do is crushing the salt. You can see the roller there and the spring base, which kind of crushes the salt and turns it into a finer powder, and then it will go onto the material belt, and then that's when it goes. That belt carries it to the back of the truck to the actual spreader. And like I said, the Epoke Theory is to kind of crush the salt, and they also apply liquids at a much higher rate than a standard spreader, and that's to reduce bounce and scatter. And it also reduces the amount of material that's being used, the amount of salt that's being used, by increasing your liquids. And the unique thing about the Epoke is that it can spread material up to 3 lanes in one pass. You can do the lane right behind you, and then you can select they call it telemetry, to spread to lanes to the right or left, or going both directions. This figure shows the Epoke System. You can see it mounted on the ODOT truck that was used in the study. And as I previously said, the Epoke that was studied was the Series AST Combi S4902. That's kind of their highway combi spreader. Means it's liquid and dry material. And this is kind of they're one of their top of the line units that's used for multi-lane highways. You can see the gray tanks in that picture. That's where the liquid is stored. We had 1,100 gallons of liquid tanks on this truck. And then the orange hopper is where the salt is stored. Obviously, just drop it down in from the top. I talked about the controller a little bit before, but this is what the operator uses to adjust the amount of salt and liquid being applied. On the earlier figure, there were some knobs at the bottom of the screen, and that's how they turn up or down their application rates for the dry and the liquid. And it's also how they adjust the number of lanes and the telemetry to adjust which direction they're spreading. And then I talked about the EpoSat, which gives the option to record and navigate routes. So before a storm, the operator can go and drive a route as they normally would. And that includes changing all of their application rates and their direction that they would be spreading. and you can do that in record mode, and then it will record all of your routes, and then you can actually go back out, and when you're in the actual event, you can select your route that you want to maintain, and it will give you turn-by-turn directions, and the EpoSat will actually control your spreading operations for you. So all the operator would have to do is drive the route and control the plow. So that was a big, safety improvement. Letting the operators focus more on traffic and driving than having to keep adjusting for different lanes and things like that. I guess this is the slide that talks more about the EpoSat. Like I said, it's capable of recording the routes and the spreader controls. The program comes along with the actual controller that allows you to go into the computer program and modify the routes. You can actually change like the audible turn warning. You can move those closer or further to an intersection. And say you were on a 2-lane road and you forgot to, or on a 3-lane road and you were only spreading over 2 lanes, you can actually go back into the program and modify that so the spreader will change and spread over 3 lanes. You can basically, anything that you can do in the field, you can modify in the program.
Yeah. With EpoSat, can you actually create the entire route from computer without having to drive the route itself?
I don't believe so. You can just modify it. I don't know if everyone heard the question. There's a question of, in the computer program with the EpoSat, can you create the routes rather than driving and recording the routes? And I believe that you have to record the routes, and then you can only modify them in the computer program.
Hey, this is Randy in the District 7. One question for you. That's the truck you were showing me with the cheater axle on it before that. How much granular material and liquid does that hold again? We were cut off on a phone. Our phones were cut off for a second.
Okay. Could everyone hear that question?
Yeah, I can hear that.
Okay. So it holds 1,100 gallons of liquid, which is in the gray tanks shown there, and it holds 5 tons of salt, which would be in the orange part of the hopper.
Okay, that's all I needed. Thank you very much.
You're welcome.
Now ask Dan the question, because he's on the phone.
Okay. Dan from Epoke, you're on the line here. Was I correct in saying that you cannot create routes in the EpoSat program? You can only modify them? Okay. If Dan comes on...
He's typing.
Oh, he's typing. Okay.
Do you want to go to the next screen and we'll catch up with you?
Yeah, we can move on and then we'll catch back up with Dan when he types out his response. As I said before, we did use the Epoke on a tanker truck for anti-icing operations, and the tanker holds 5,000 gallons of brine. This is the only one in America that has an Epoke hooked up onto the tanker truck like this. So really they use that for their highways and like State Route 8, which is a larger state route, for turning operation. It was hard to, turn such a large truck around, so they kept it on their larger roads where, they could use interchanges to turn around. And this really provided the ability to anti-ice over the entire lane, over 3 lanes, 2 lanes, depending on how they did that. So that was a big time savings for the guys up in ODOT. This is kind of talking about the weather data collection. We used NOAA's National Operational Hydraulic Remote Sensing Center. So they have weather stations throughout the U.S. And we located 2 that were right near both of the study zones. The one was in Cuyahoga Falls near the State Route 8 study zone in the first winter. The second one was in Macedonia, right near 271 for the second winter season. And as I said before, we kind of characterized the storms based on observations that we saw. So we used pretreatment and then light snowfall, which was less than 2 inches of snow in the day, and a peak snowfall of less than 1/4 inch per hour. Moderate snowfall 2 to 6 inches, and between 1/4 and 3/4 inch per hour. And then heavy snowfall greater than 6 inches and greater than 3/4 of an inch of snowfall per hour.
I have a response from Dan on the list.
Okay. So Dan's response, you must create the route on the route, either with the truck or a simulator. So you do have to actually go out and record the routes or use the simulator to create the routes, and then you can modify them in the computer. So you cannot create the route in the computer.
Okay, thank you.
Yeah, thanks, Dan. So one of the main areas of data that we needed to collect for this study was the in-truck data. So in order to compare the Epoke and the standard truck, we needed to record, these various data here: the salt usage, the brine usage, the mileage traveled, the number of lanes treated. Which was unique to the Epoke. The standard truck was only treating one lane at a time, and we also looked at the plowing, just so we could account for all the winter maintenance activities that were occurring.
We've had a question from Alaska.
Okay. Question from Alaska. Can you tie in on truck weather equipment?
I don't know.
It'd probably be the pavement and air sensors and things like that.
Oh, okay.
Information.
Okay. So I think you're asking tying in like pavement and air sensors, and I don't think that gets tied into the EPOSAT. At least Epoke didn't tell us that was a possibility. As far as doing it yourself, you may be able to, and then I don't know if you can use their uploading system, but.
Looks like they're going to type a clarification. So
Okay.
Keep going, and then we'll catch it in a minute.
Okay. It looks like they're typing in.
Oh, yeah.
Oh, that was a question. Okay. All right. Go on. So to collect the data from the trucks, we used 3 techniques. The first one is using ODOT's standard M&R 661 form. And initially we were just having the operators fill them out as they normally do. So periodically during an event, when they had a break, they would go back through and fill in where they went, how much salt they used, some of their treatment options and road conditions. But for the research purpose, we were looking for kind of very fine level of data, and it's we can't expect the operators to pull over every 2 minutes and record when they changed a lane, or when they were treating 2 lanes versus 3. So that kind of led us to our second technique, which is when we placed students in the trucks to ride along with the operators. So they would actually just go ahead and fill out the 661 forms for the operators, and that way the operator could focus on doing their job while the students could fill in the data every time, say they treated multiple lanes, every time they changed an application rate, just so we could record a much higher level of data, for our purposes. And then they would still, they would provide their form to the operators at the end of the day, so the operators could go ahead and fill in their forms. And then, with this project, we had multiple students filling out the forms, which, kind of created a lot of data interpretation time, and there was, little consistency amongst the forms, so kind of some issues that we had to deal with on our side.
There's a response from Dan concerning the
Okay.
from Alaska.
Dan said that truck weather equipment can be tied into the Epoke data stream, but it doesn't tie into EPOSAT. So the weather factors can be considered when selecting the EPOSAT route application, i.e. snow versus freezing rain. So you can tie those in, but not directly to the EPOSAT. So getting to the third data collection technique that we used, this is kind of when we went, the real research route, and we created a data collection program. So we actually gave the students mini laptops where they could fill in this data while they're riding along in the truck. They could just, tab over to every column and type in the values. And this is just a simple offline PHP program that's saved locally to the computers. So after every storm, we would go out and collect the data. But it was much more organized, consistent, kind of in a database form, so it was easy to handle for us. While the students were out there, we sent them out with GPS units. You can see that in the first picture there. So we use those just to kind of spot check the students who are in the trucks. So we could say, at this time, they have a solid application rate of, a certain value on this road. Then we could go back and say, okay, on the GPS, yeah, they were in that area. And we also use the GPSs to validate a route optimization model, which we'll talk about a little later. The units that we selected, the GPS units, they gave output into Google Earth or a Microsoft Excel file, which could be converted to a CSV and imported into ArcGIS, which was used to validate the route optimization model. I talked a little bit before about the speed data collection and how we use Bluetooth nodes. So really what the Bluetooth nodes do is we would put multiple of them along the roadway, as I showed at the beginning. And we would, by knowing the exact location of the nodes and the distance between the two, when we got multiple MAC addresses recorded, or a MAC address recorded on multiple nodes, we could calculate a space mean speed based on the time difference and knowing the distance between them. So these were just, they're portable nodes. You can see them in the case there. That way, if we change study zones, it was easy to just pick them up and move them. And those are battery powered. That's a Pelican case, so about the size of a briefcase box that we would just lock to a guardrail. And within the nodes, there's just a Bluetooth radio, computer board with USB, Bluetooth antenna to actually read the MAC address on passing devices, a Verizon 3G wireless card so that we could automatically upload the data to our server, power regulators and batteries. And so we would maintain these weekly. The batteries lasted about 2 weeks, but in the wintertime, the harsh conditions, we would go out and change the batteries every week and kind of, scrape the snow off the boxes. So, this is just showing a sample of the way that we combined the MAC address speeds and the weather. So you can see this is a storm. This is the first winter event from last winter, December 21st. You can see kind of the feeling that we had is that the operators or the vehicles, they're going to drive at whatever speed they feel comfortable with. So you can see even during the winter event there, kind of around 5 p.m. so a little bit of rush hour, and it had been snowing throughout the day, so you get a lot more vehicles out there. You can still see some people are driving quicker than the others. And then comparing the northbound and southbound speeds from about 5 to 7 p.m. You can see the southbound speeds are more varied. There's a larger gap, the highest between the high and the low speeds. And in the northbound direction, there's a very thin band. That's actually because there was a crash that day in the northbound direction. So that kind of shows you that when there's a crash, your variability in speeds is very small compared to just a regular winter event when all of your lanes are still open. You will still get a couple of drivers who are going faster, and people can kind of choose the speed that they want to go a little more. So that kind of gave us a basis for people are going to drive at whatever speed they feel comfortable with during winter events.
So the southbound lane reflection is like rubbernecking?
The northbound, yeah, the red ones.
Yeah.
Yeah.
I mean, the other direction. I mean, no, that's snow.
Yeah, that's snow too. Yeah.
Both dry.
Yeah, the green line there is the snowfall. That's the hourly snowfall that was occurring. What's that?
For online?
Oh, okay. We had a question here that was the southbound speeds depicting rubbernecking, and it was some people would be slowing down to look at the crash, but that's also a result of the snowfall causing the speeds to drop down as well. This is just showing kind of some more sample graphs there of the speeds during the first winter season. So you can see the Bluetooth node locations again, and kind of just a sample speed there on Route 8. So you can see kind of in the afternoon there when the snowfall picks up, you really see your speeds are kind of starting to dive down, as a result of the snowfall. These are a couple figures of the second winter season. So just the study zone that was set up on I-271, and kind of 2 days showing, some increased snowfall. The first one, December 26th, that was actually the largest snowstorm that we had that winter. And you can see, as the snowfall really starts picking up, your vehicles are really slowing down. And even for a lighter snowfall there on February 16th, you can still see, your snowfall is picking up, and it's not too heavy of a snowstorm, but you can see vehicles are still slowing down You know, the snow's falling, the roads are kind of getting covered and slick maybe, so everyone's, you know, feeling like they need to slow down some.
It's dark by then too, so.
Yeah.
Remember the level of snow was pretty mild.
Yeah, it was mild snowfall that we had. So this kind of shows an overview of the weather events. As we said, over the 2 winter seasons, 39 winter events occurred, and it says 47 over there for the total events, but we were including some of the pre-treatment events that didn't have snowfall included afterwards. So there were times that ODOT sent vehicles out to anti-ice before a snowstorm, and it didn't actually end up snowing that day, but we still counted those as just the pre-treatment events in our evaluation. So there were 29 events where material was actually spread, and 12 of those were good comparison events. 7 were events when one of the trucks was out due to maintenance, and only one of those was when the actual Epoke was out, only one of those was the result of the Epoke spreader being down for maintenance. The other 6 were issues with the truck that the Epoke was placed on. And then we had 10 events that were not good comparison events, and we'll talk a little bit more about that. So this shows how we calculated the total amount of salt used by both the Epoke and the standard truck. So Epoke's pre-wetted salt has a salt-to-liquid ratio of 70:30, and that can be adjusted in 5% increments. And the maximum ratio is 70% dry material and 30% liquid, and that's what ODOT used throughout the study. Excuse me. And the standard truck applies brine at a rate of 7 gallons per ton of salt. So for every ton of salt, they're applying 7 gallons of brine additionally to that. And ODOT, their brine mixture is 23.3% salt. So those are all kind of factors that we included into our total salt calculation. So kind of going down to this figure, you can see the salt. We looked at the salt application rates, the start and finish mile markers that the students recorded for when they were actually treating, and the number of lanes treated for the Epoke, and all went into the total material applied. And then coming down to the standard truck, we used 100% of the dry material because they added liquid additionally to that. So then we also got the percentage of salt that was being used in the brine that they were adding on top of the dry material. And then for the Epoke, we took 70% of their application rate as dry material and 30% as the liquid, of which 23.3% of that was salt. And then if the operator was applying additional brine to the mixture, we looked at 23.3% of that as being salt. So kind of a disclaimer from this point forward, anytime we're talking about the amount of salt used, we're including the salt from the brine, we're including all of the salt that is being applied for both trucks. So these are some of the equations that we developed to actually calculate the salt. So the first one I talked about, the total material applied. You look at your application rate times the number of lanes treated times the length of the application, which was the difference in the mile markers. Then we still accounted for the total liquid applied, which same equation, you just change out your application rate from dry to liquid material. And then for the standard truck, as I said, your total salt applied is the total material applied plus the total material applied times 0.008%. So that is that 0.008 is a kind of conversion factor that takes into account the 7 gallons of liquid that they're adding per ton and the 23.3% of that being salt. So that's just a conversion rate that we calculated in our lab. And then for the Epoke, the total salt used, again, you take your total pre-wetted material application rate times 0.7 to get the 70% of that is the dry material. And then you add the 30% of your material applied times the 23.3% being brine. And then your total liquid, if you're adding that additionally, we added in that 23.3% of that was salt. So that's it for the lengthy equations. So we kind of looked at some of the factors that affect salt loss. So we'll go into this a little bit. You have your initial loss that's bounce and scatter related. So when the material hits the road, how much of it actually stays on the road versus how much of it bounces off. And pre-wetted salt, it has less initial loss than dry material. That liquid actually helps it stick on the road. And then you have your salt dissolution. So over time, and as traffic is driving over it, and moisture comes in, you do lose some of that salt, and that's why it doesn't just last forever. And actually, pre-wetted salt dissolves faster than dry salt. Thank you. So then you have your loss after application. So spray off, how much salt gets lost by vehicles driving over the roads and over the salt. Blow off, the removal of the solid grains, again, that's traffic related. Then your runoff, your roads are crowned, and as the roads get liquid on them, some of that salt does just kind of seep off the end of the roads. So for dry salt, you lose 30 to 40% just due to the initial loss for bounce and scatter, as we talked about, and pre-wetted, it's only about 4 to 8%. So you can see a couple figures there, just kind of comparing your initial loss rates and the kind of the amount of bounce and scatter for the different pre-wetted versus non-pre-wetted in the different lanes. So as we said, for salt to be effective, it must dissolve. So dry salt doesn't really do much. It has to get activated by the water for it to start working. And obviously pre-wetted salt will dissolve more quickly because of the higher amount of water and the smaller grain size from the epoke actually crushing the salt. And so a decrease in particle size will result in an increased dissolution rate, so that will activate quickly. So the loss after application primarily is caused from traffic spray-off, so from vehicles actually driving over the salt. And it's a factor of dissolution rate. More liquid will result in more spray-off, and that's kind of shown in the figure there. When you have your salt amount compared to your actual traffic, you can see that the wet road surface is losing its salt much more quickly than a dry road surface. So here we're going to get into some of our salt usage results. Again, we tracked all of the salt that was applied by the Epoke and the standard truck. And we kind of hinted at this before, but we're going to divide this into two sections. The salt usage on the good comparison days and the salt usage on the days when the Epoke was out of service. So this figure here shows the salt applied by each truck on the good comparison days. And with these figures, the Epoke is always going to be in blue and the standard truck will always be in red. We kind of kept that consistent so everyone is kind of on the same page. There's 12 days in which the Epoke and standard truck were both operational and always treated opposite sides of the study zone. So they never crossed over or treated the other direction. And kind of going into this figure, there's only 11 days shown, and that's because one of the days was removed and we called it a training day. It was one of the earlier times that the operators really kind of used the Epoke quite a bit, and there were some issues that came out from using that, and we'll talk a lot more about that later on. We called that a training day because we kind of had to sit down with the guys and really show them, what they were doing. And also, there are days here, January 26th, February 28th, and March 1st, where only one of the trucks treated. So we pulled those days out as well. That was after we kind of talked with the technical liaisons here. And we did go back and we looked at the GPS units and the salt data and everything. And on those days, both of the trucks traveled through the study zones. It was just for one reason or another, only one of the trucks treated. That kind of goes back to ODOT always just kind of letting their operators, do their job as they feel necessary. So the one operator, the roads conditions weren't bad enough where they needed to apply material, plowing or another sort of maintenance operation was good enough. So kind of going into some numbers here, the total salt used by the Epoke was 9,757 pounds, and for the standard truck it was 11,103 pounds. So on these good comparison days, which end up being about 8 days total, the Epoke used 12% less salt compared to the standard truck. Okay, this is the salt usage when the Epoke is out of service. And as I said before, there were 7 days in which the Epoke truck was out of service, and only one of those days was actually a result of an equipment problem with the Epoke.
I have a question that's coming from Akron that relates to the last slide.
Okay, we have a question here. On the 3 days where the Epoke used more salt, what was the cause/difference with those storms? That kind of goes back to the operators. That's kind of how they used the equipment and how they felt. Those guys really, they let the operators do and treat as they felt necessary. So there was, the storms were kind of, all similar on a lot of these days. It just happened to be that the operators used more salt in one direction as compared to the other direction. And kind of a response from Frank Phillips. He was the county manager for Summit County. He says it's the operator's comfort zone and learning the Epoke. So there was a bit of kind of a learning curve at the beginning of the project, where the operators, we kind of had to almost train them into how to properly use the Epoke, so that they would actually, use it properly and to the best of its abilities.
I passed it back.
Okay. So this is where we were comparing the days when the Epoke was out of service, as I said. And you can see the northbound and southbound total salt usage values there are nearly the same. Both 12,900 versus 12,300. So there was no directional bias, as in one lane of traffic or one direction of the highway, was typically using more salt. Because on these days, just 2 standard trucks were used to treat the same study zone instead of the Epoke and the standard truck. Kind of getting into summarize some of the speed trends that we realized during the project. So we compared the northbound speeds and the southbound speeds to kind of look into any differences in the level of service between the Epoke and the standard truck. And you can see the baseline speeds for both northbound and southbound directions are 67 miles per hour, and that's a 65 mile per hour speed limit there. And the speeds during the winter event, again, it was a milder winter, so really the average speed during the winter. So one of the things that we did look at by combining the Bluetooth speeds and the weather data, and ODOT's kind of using this as a performance metric, is the regain time. And that's the amount of time required to return the vehicle speeds to within 10 miles per hour of the baseline conditions after a winter storm has ended. So we kept the Bluetooth nodes out there from December to March, so that way we could record speeds during the winter events as well as just a regular day, so that we could develop the baseline speed trends for both areas, which, going back to the last slide, that was 67 miles per hour. So kind of this figure showing here, this is from December 29th, kind of an earlier event in the winter season. You can see the one black line going horizontally. We set it at 55 miles per hour. We don't want to account for average traffic going over the speed limit. I mean, typically as an engineer, you don't design for people not doing what they're supposed to do. So we still kept the speeds at 55 to hit that as the regain time. And then you can see the vertical black line kind of signifies the end of the event. And we did have some debate on what actually constitutes the end of a snow event. Is it just when the snowfall stops? Because then you still may have to deal with blowing snow and things like that after the fact. But for this, we just looked at when the snow stops. We called that the end of the winter event. And so kind of at in the table on the right, summarizing the average regain time in the northbound direction, which was the direction maintained by the standard truck, the average regain time was 26 minutes, and for the direction maintained by the Epoke, it was 18 minutes. So there was a little benefit added there for the Epoke. This is talking about using the tanker truck for pretreatment. Again, ODOT placed the Epoke spreader on a 5,000 gallon tanker truck, and before they used that tanker truck, it took 4 trucks 12 to 14 hours to pre-treat the routes, and then with the tanker truck, it took the one vehicle 6 to 8 hours. Unfortunately, there was only 11 events where exclusively pretreatment was performed with the tanker truck. So there were other events, but they used multiple trucks where they hadn't had the tanker truck equipped at that point. So this kind of shows an overview. Oh, got a question.
So the 12 to 14 hours, is that each truck?
That was
12 hours?
total. That was total.
Total, so
Yeah.
3 hours
Mhm.
for 4 trucks.
Yes.
that kind of thing.
Yep.
Thank
Yep.
you.
So the question was the 12 to 14 hours, was that per truck or was that the total time? And that was the total time. It took the 3 or 4 trucks, depending on how many they used that day. It took them a total time of 12 to 14 hours.
Thanks.
Yep. So going into kind of a summary of one of the pretreatment events, this is December 6th, 2012. This day there wasn't actually any snowfall that ended up occurring, but they did use the tanker truck to pretreat because snow was forecasted. So the truck traveled 69 miles on the routes you can see there, I-271 and State Route 8, shown in the figure on the right. And they treated 152 lane miles with 1,200 gallons of brine. And to treat both of those routes, it took just under 2 hours. And so, as we said before, the main benefit of using this tanker truck for pretreatment is that you have the ability to spread material over multiple lanes in one pass. So instead of having to loop back around, you can just hit the highway once.
For the current device on that truck, could it use de-icing? Could the rates be increased enough to de-ice as well?
Yeah, yes. Yeah, they can, so we had a question of, oh, go ahead.
So I was saying, was they trying to understand the project?
Okay. We had a question of, can the rates be increased enough to use that for de-icing and not just anti-icing? And yes, the rates, it was the same type of controller where the rate was variable, and they could have turned it up enough to use that for de-icing as well. Did you have another part of the question?
Was that performed during the
No.
project at all?
No. They asked, another question to follow up was, did they use it for de-icing during the project? And no, they did not. So getting into some of the cost analysis, we found 2 main areas of savings with the Epoke, labor savings and salt savings. And so we evaluated the labor savings in kind of 3 manners. We looked at the values that we found on the good comparison events, and the value that we found on the route optimization model. And then we looked at, based on the roads that are in Boston Heights maintenance area, what is the maximum possible labor savings that the Epoke could provide. So we looked at the average number of events per year. We found that, looking back over, I think 5 or 6 winter seasons, to be 56 events per year. And we were obviously much less than that during our study period. And using 12 hours as the average duration of an event, and using the straight time labor rate of $17.60, you can see the 3 different labor savings values per year from using the Epoke. 7,000, 3,500, and 13,000 would be the maximum. So this is going into the salt savings from using the Epoke. We looked at 2 kind of total salt usage values for a garage of 20,000 tons and 10,000 tons of salt used annually. And so kind of the note at the bottom, this is used, or these values are for a truck with 6, or for a garage with 6 trucks, with 1 of them being an Epoke and 5 of them being a standard truck. We kind of just, kept that. That's what Boston Heights used. That was our data, so we kind of just kept everything for using what we did in the field. And we.
Comment from the Boston Heights
Okay.
manager there.
Frank, he has a comment here. The reason we didn't de-ice was at the time we had an old truck, and it was hard to drive during an event. Now we have a newer truck, and they're planning on de-icing more. So the truck that they had the tanker on was kind of an older truck, and now that they do plan on using it for de-icing this winter. So getting into the salt savings here, again, the value that we found from our kind of only a few events was the 12% salt savings. And so, we looked at the amount of salt that would be used by the Epoke in the two different scenarios, and then looking at the total tons of salt saved per winter season, and using the current price of salt that Boston Heights had last winter of $37, we found a salt savings of $14,800 or $7,400, depending on which scenario for the total salt used that you're going to apply. So this figure, this shows kind of the payback period, or how long would it take to recoup your investment on the Epoke. And again, we kept the two scenarios with 20,000 tons or 10,000 tons, and we looked at, or we varied the payback period based on the price of salt. So obviously, the more expensive salt is, the quicker that you could pay back your equipment on. So we kind of looked at $40 per ton, just a little bit of an price increase compared to last winter. And for the Epoke, it would pay itself back in 8 years if your garage is using 20,000 tons of salt annually, or in year 14 if you're using 10,000 tons of salt annually. And at the bottom, this table below, this kind of just shows what assumptions that were used in making this table. It says salt savings of 16%. That was apparently not updated. The value there is supposed to be 12%. When we removed some of those days that I talked about previously, we did have to readjust the percentage. Oh, I apologize, I'm coughing quite a bit now. Okay, so this figure shows the payback period for the anti-icing tanker truck, and we looked at, we varied it based on the number of lane miles saved per each year, and so we found that the tanker truck saved 1,800 miles based on the number of events that it was used for, and so based on that value, ODOT would not see a return on using the tanker truck. We have a question here. Oh.
What about, we also, it's important to mention on these costs that we did not consider user costs in any of our accounts. So nothing for the actual driver. The thought is at the end of the day, ODOT can't write a check against the cost savings to the community. So.
We had a comment here, and it's just that we did not use user savings or user costs to this, so we didn't apply any sort of monetary value to being able to do the winter maintenance operations quicker. ODOT, they can't actually write a check for the roads being clear of snow sooner. But that is one thing that Frank Phillips did express with the Epoke tanker, is although they may not see the actual monetary return just based on just the savings of it, there are other benefits to having the tanker truck, and the main one is getting the roads open quicker, getting their operations done sooner, and decreasing the number of operators that's needed, so those operators can do other things during that time. So before we talked about the February 16th date as kind of being a training day, and we'll get into that a little bit more here. Operators within ODOT, they have the ability to apply material at their desired rate. So based on how they feel the road conditions are, they can select the rate that they feel is necessary. And with the Epoke, there is the potential to over-treat. And we kind of, we mentioned this before, that we did have several meetings with the operators and the managers in the garage to kind of show them some of the outcomes that could happen. And to hopefully ease those issues. And we do look at an implementation strategy here. What is the most economical route to implement the Epoke on? And we did get, we looked for operator input, and we did run a lot of test runs with the operators to make sure that the routes were feasible. So this is getting into the February 16th event. The figure to the left shows the salt applied by both the Epoke and the standard truck just on this date. So those times, they're not in any sort of categorical fashion. That's just the actual time that the route was treated at. So you can see in the table, the Epoke applied 6,554 pounds of salt in the study zone, while the standard truck applied 3,326. And going to the figure, the trucks treated the same number of times. I think it's 7 for the standard truck and 6, or 7 for the Epoke and 6 for the standard truck. So you would expect similar salt usage values based on the similar number of times treating. But the issue was the operators were treating multiple lanes in each pass, and they were making a similar number of passes as with the standard truck. So this is when we kind of had to go back. We made a lot of graphs to kind of show to the operators, and we kind of really had to explain to them, there is really the issue to overutilize the Epoke. And if you are going to make that number of passes, you can only treat one lane at a time. If you do need to plow both lanes, only spread the material in one lane, or reduce the number of passes. And then the operators, during this dialogue, they kind of came back at us and they said, well, we're not really comfortable, not going down roads or things like that, or going a long ways out and having to deadhead back. So we did kind of have to come to a bit of a compromise to kind of figure things out with how they could implement it, based on how they could also see a good salt savings with the truck. And then the one thing we do show with the speed graphs is even though they did over-treat with the Epoke, the speeds are still essentially the same going in each direction. So even though they were over-treating and applied much more salt, it didn't really have much of an impact on the roadway. And this kind of shows the routes of the two trucks. You can see that the Epoke and the standard truck on this day, they were basically maintaining the same area, just a little different part of 303 each truck maintained. I kind of talked before about the route optimization model that we developed. We used ArcGIS to develop just a route optimization model, and we were able to implement the Epoke into the model to determine what is actually the best route to deploy the Epoke on in Boston Heights Garage. So we looked at the different cycle times to complete each route. So we broke it out based on which garage they were in. So that included, we have Boston Heights there. That included all of the routes that Boston Heights maintains. And then within the model, we implemented the Epoke on State Route 8 and also I-271 to see where was the major time savings. We only selected those two routes because those are the main multi-lane highways within Boston Heights. So that's why we didn't look at State Route 303 or some of the smaller roads that Boston Heights maintains. And from the model, and you can see in the figure, the most time savings was when the Epoke was implemented on I-271. And using it on State Route 8, it was a time savings, but just not as much as using it on 271. Some of the implementation, using the tanker for pretreatment, that saved a lot of time. There was, those savings to be found there. The route optimization model, we had to validate the route because we didn't want to just say, oh, this is a computer model, this is what it tells us. That's why we actually put all the GPS units in the trucks so that we could go back and actually look at what the actual cycle times were. And then we did update our model. It ended up being about 30% longer cycle times from what the model said before we went back in and adjusted it. That's because we overestimated the amount of time that it took the trucks to turn around and things like that. So we did end up modifying those. And kind of our feeling in talking to ODOT is that the Epoke is best suited for light snow. And that's because when the Epoke is plowing, it can really only spread the material in one lane, or else you risk plowing off when you come back around. But you would still see the salt savings even if it was only spreading in one lane, because adding in the additional liquid and that it still would reduce the total amount of salt that you're using. So this is kind of an implementation strategy that we did come up with, and you can see if you do use the Epoke in heavier snow events where plowing is necessary, which the Boston Heights garage did do, you could put the Epoke as the last truck. So the Epoke was used in this sort of manner. And then another strategy that we kind of came up with was if you are going to have the Epoke, maybe it makes sense to shift the trucks based on the storms. So we found the Epoke is equivalent to about 1.6 standard trucks. So if you have a heavier snowstorm that's coming in maybe to the northern part of Summit County, you could shift 2 trucks from a garage down there and replace it with the one Epoke. So that way the 2 trucks will be able to do some of the more heavier plowing, whereas the Epoke could be shifted down and it could cover both of the routes just with its treating, its liquid and dry material treating. So in conclusion, the salt savings from the Epoke, it reduces bounce and scatter, which obviously helps keep more salt on the road, so you would have to come back and apply material less frequently. And also the 70 to 30 salt to liquid ratio, that helps out with the salt savings there. We did find that there were studies out there that showed a higher water content and accumulating traffic will result in quicker salt removal. So the increased liquids, they do activate the salt quicker, but there is a chance that the salt will come off the road quicker. And the Epoke, it's best suited for the pretreatment. Obviously, with its liquid capabilities that is kind of unique to the Epoke, that makes it good for the anti-icing. And the lighter snow events, as we talked about, being able to treat multiple lanes when it doesn't have to plow, that could really provide some benefits there. And we did find that the Epoke has the time savings over the standard spreader because it is capable of treating over multiple lanes in a single pass. This is kind of summarizing the salt savings that we found. Again, the 12% that we found on the good comparison days, and then the maximum possible for ODOT that we found was 18%, and that's because ODOT is using brine that has salt in it as their liquid. So there is the potential that, based on other locales doing different things, that they could see a higher salt savings. And ODOT's salt savings is a little decreased because they typically are using pre-wetted salt already. So there are areas that are still using dry material that they would see a larger salt savings just based on the increased liquids. And again, the savings that we found, they were all in lighter snowfalls and not there was a far below average winter seasons. And at this time, we'll open it up for questions. Anyone on the phone or typing in questions?
This is Randy in District 7. I got a question for you. When you're pre-treating 3 lanes or even, treating 3 lanes, any complaints from drivers?
Okay, we had a question. When you're treating multiple lanes or pre-treating multiple lanes, did we have any complaints from drivers?
Yeah, flashback, chips, you know how that goes.
Yeah, we actually did not, or at least that I know of. Yeah, Frank says no. And yeah, there was no, the operators or the vehicles, no one complained to us.
Okay, one other thing, when you obviously you can run a less salt pounds per mile with this Epoke system and more liquids. How much more liquids were you running per ton on the Epoke system? I probably heard that and just didn't write it down.
We ran the Epoke. They always use the maximum 70 to 30%. Or 70 to 30 ratio, so they're using 30% liquid. And then there were times where the operators would add additional liquid into that. Yeah, and Frank says 30 gallons per ton. that they're adding in additionally. And when they were adding in the additional liquid on top of just the standard pre-wetted, it's kind of up to the operators to scale back the amount of dry material that they're using.
Fantastic. Thanks.
Thank you.
Frank, there's a question from another Frank.
Okay. Your estimate is based on 8 data points, I think. Did you estimate any range of uncertainty for your percent savings? Is it 12 plus or minus 1%, or more like 12 plus or minus 10%? And we had those discussions with ODOT and our technical liaisons, and with the variability that a regular truck driver does apply their salt at an application rate that they feel is comfortable with. We did not apply any uncertainty. We did discuss that there is an uncertainty range, but we didn't actually define what it is.
You mentioned for your payback value for your Epoke system, I think it was like 14 years, I believe.
Yeah.
Does the manufacturer, I know he's on the line, does he give just an estimate of how long that Epoke system should last?
Okay, we had a question of the payback time on the Epoke we found to be in year 8 or 14, depending on the total amount of salt you used. And the question was, what is the amount of time that an Epoke is expected to last? And I believe they guarantee parts for 15 years, and they expect the Epoke to last up to 20 to 30 years. And Dan, if you want to comment on that.
Dan's a different comment.
Okay. Okay. Frank says we're confident the more snow we get and the more driver confidence builds, the savings can grow. And so that is, the drivers do need to get more comfortable in the truck and realize that they can turn down, their application rates based on the increased liquid rates.
Okay.
Yeah, Dan said 15-year part availability guarantee and 20-year plus life cycle. I believe he did indicate to us that they have a lot of units in Canada that are, around 30 years old, but, that 20 to 30 range is what he told us during the study.
Thank you.
There's a comment from the other Frank.
Some statistical analysis could give you a range of uncertainty, I think. We could have applied, a lot of measures to get, different uncertainties. And again, it kind of goes back to the operators being able to do whatever is comfortable.
There's only 8 events, and so
Yeah.
the range is going to be
Yeah.
big anyway.
Yeah, and with the limited number of events, that does add in a lot of uncertainty. So,
Yeah.
do you have a trade-off in the cost-benefit space for cost versus level of service? Maybe a Pareto space. So we did not, as we said, we did not apply any sort of user benefits because that's not an actual value that ODOT can consider. ODOT can't say, oh, we opened the road an hour quicker, so that for that reason we saved X dollars. So again, talking with the technical liaisons, we did not include those values into our analysis. All right, well, I'd like to thank everyone for their time. Thank you for never mind, we have a question here. If you were to do the study again, what would you do differently?
More snow events.
More snow events. Yeah, if we could have made it snow more, that would have been the best. Yeah, I mean, maybe...
More driver training.
Yeah, more driver training, Frank says. So. All right, thank you everyone for your time. Thank you for the questions. I don't know if they want to send in. Oh. Okay, a comment from Epoke here. These savings are low, are low relative to results in other areas. As Frank has said, more events and operator training will result in more savings. That's we do agree with that. With the operators being more comfortable with the system, we do expect those savings to increase.
But the savings will increase across both lines of vehicles.
If you were to train your others.
As operating and training improves across the board, the salt savings across the board will also increase.
Yeah, yeah.
Or sorry, the salt savings will also increase.
Yeah. So the comment here was, that savings, as the operators get more comfortable and more training, the salt savings would increase across the board for all of the trucks and all of the operators.
The Epoke has the ability to lock out the driver from changing the salt application rates. Reality of it is it's under ODOT's current system. ODOT allows the driver to make the call while they are driving.
Yeah. So the Epoke, it does have the ability to lock out the rates, so they can't go above a certain value. But ODOT's, their kind of practice is to let the operators select whatever rate they feel necessary. So
We can lock our trucks out too.
Yeah.
Rate, we choose not to.
Yeah.
We can still do that.
Yeah, the standard ODOT trucks, they can lock them out as well, but they choose not to. With the other truck spraying brine also. The other truck, it was just pre-wetting its salt at the spinner. Yeah, it was pre-wetting its salt at the spinner, but it was not applying additional brine. And I think we're going to get a comment from Frank. Yeah, Frank, he's just reiterating, it was pre-wetting at 7 gallons per ton, which is the ODOT standard, at least in Summit County.
One of your conclusions, Epoke best suited for pretreatment and light snow events.
Mm-hmm.
But it makes more sense then that these would be in use in the, say, the second and lowest tier of the state where we do get those lighter snow events?
So the question here was, one of our conclusions, we said that the Epoke is best utilized for pretreatment and lighter snow events. And so the question was, would we recommend the Epoke for in the lower or the southern portion of Ohio where they receive less snow? Yeah, it would be useful there. And we'd also talked about just up in the snow belt, just kind of moving it to the southern part of the snow belt, just to get it so if there is a major plowing event, it would be almost more useful in an area where it could treat over multiple lanes. So any of your multi-lane freeways where plowing maybe doesn't need to plow quite as often, that would be where the most savings will be found. So we have a comment going back to the brine, and it's only using the pre-wetting at the spinner. The standard truck would get more scatter than the Epoke. And yes, that is true. We did kind of hint at that. We probably didn't cover it enough, but the Epoke, it does have much less bounce and scatter than a standard truck based on those increased liquid rates.
Yeah, but you still stand by what savings you were, I mean, we looked at all that.
Yeah.
The reality of it is that the level of service on the road as defined by the user as a surrogate measure of speed did not vary. So you look at the total pounds placed on the road, and you looked at the speed on the road, it's adequate.
Yeah, so going a little bit more into that, we looked at the speeds in both of the directions, and we kind of used those as surrogate measures for a level of service. And based on the two trucks, those speeds were the same. So there was the decreased amount of salt used by the Epoke, resulting in the same level of service for both directions of travel.
I mean, the reality of it is ODOT's not going to allow us to go on Route 8 in the middle of a snowstorm and count how many specks of salt bounce off the road. It's not going to happen. So you got to come up with speed, and if you're going to assess it as regain time, there you go.
All right, it looks like we haven't had any more questions here for a little bit, so we're going to go ahead and disconnect. Again, I'd just like to thank everyone for taking the time to listen in and send in some questions today. Thank you.